So today we're going to talk about efficient workflow solutions, and in particular how we use macros to achieve this, and coupled with some of the Ecodesign's efficient design tools that we have created. So it should be an interesting one, actually my favorite subject. So for those of you who don't know me, my name is Segrin Govinder, and I'm the director of Ecodesign. And I sort of take care of the sales, mostly the Eplan sales, new sales, and so forth. So I'm joined by Farhana. Farhana takes care of our renewals. And so you would have seen emails from her regarding renewals, and she also sends out the webinar invitations and so forth. So you can contact her via email, farhana@ecodesign.net.nz or eplan@ecodesign. Either one works. Guys, if you've got any questions, if you can please add it to the chat, and we will try and answer them at the end of the webinar in the Q&A session. This is a webinar number 2 in our 2026 series. So for those of you who missed the webinars last year we ran 10 of those webinars, and they're all on our YouTube channel. So if you go onto YouTube and you search Ecodesign, you'll come across our webinars for 2025, and you can watch any one of them. And we also put recordings of these as well on our YouTube channel. If you guys have any topics that you would like us to discuss, please send us an email, and let's just give us an idea what you would like to discuss, and we'll put it into the mix. If it's something that's fairly a short topic, we can include it in one of our webinars. If it's a sort of a larger topic, we can create a brand new webinar for that. So yeah, please feel free to do that. So the recordings will be made available for those that have registered. We'll send the recordings out most probably on Monday, and there'll be the recording will be placed on our YouTube channel in a few weeks' time. The slides and the project file can also be made available on request. So please, if you feel you need to have a look at these slides or the Eplan project, we can make that available to you on request. So we'll just run through the agenda for today, what we're gonna discuss. So I'll do a very quick introduction into Ecodesign, and also talk about some of the challenges we face in industry and possible solutions. We'll go through macros. There's an overview on macros, starting off with what's a macro, what's the difference between a schematic project and a macro project, macro types, page macros, window macros, and how we can utilize placeholder objects in window macros and page macros for that matter. How we change the value sets, and how we add variables, placeholders to handle value sets and variables. And I'll get into a demo, and I'll show you how we can insert macros just using the Eplan method, the manual method of inserting page macros and also window macros, and also assigning the variants and the value sets as well. Then I'll go into a more design automation, and how we can use macros to efficiently design together with the ESG. So I'll insert some macros via the ESG, and I'll auto-populate those variables and automatically generate the schematics. So I'll show you basically almost a fully automated workflow solution, and that will be a live demo. Then I'm also going to touch on something that's quite new, something that we've developed in the last few months, and that's our panel layout generator, PLG. And we've got 2 versions of this. We've got the basic and we've got the advanced. So I'm going to touch on the basic for today, how we can quickly insert dim rails and trunking in the 2D environment as well as the 3D environment. And again, that will be a live demo. So on the next webinar, which is webinar 3, we're going to be discussing the PLG advanced, how we can insert dim rails, trunking as well as devices in a 3D environment. And that'll be in our next webinar. So we'll finish off with just a recap on the key benefits of macros and design automation, and a quick Q&A if there's any questions that are unanswered. So let's just get started on Ecodesign, something about us. So for those of you who are not aware, we are the official distributors for Eplan, and in New Zealand that is, and we've been the distributors for the last 15 years or so. And quite recently, we became an application partner for Eplan. So what does that all mean? So as far as the distributor is concerned, we provide pre-sales support, proof of concept demos. You might have a particular application, but you want to see that working before you buy Eplan, which is only fair. So we'll create a proof of concept demo for you, make sure that it works. If you need a test license, Eplan can provide you with a test license just to make sure that you can actually achieve what you set out to before you buy Eplan. Once you buy Eplan, we provide you onboarding support, as well as training, technical support, even after the training as well, if you require technical support. That is not something we charge for. And we also create our own APIs and workflow solutions, and that is something I'll be touching on a bit later in the presentation. As an application partner, we basically get involved in co-innovation with Eplan, and in particular with the Eplan development team, so we have access to them. We also can share in their testing. So if they have a release of a new product, we take part in the beta testing. We provide feedback to them, and they also help us with our own development as well. If we need any advanced technical help, we have access to the development team. So it's quite a good partnership, and we are the only application engineer in this region. So we are Eplan certified engineers. The company has 3 Eplan certified engineers. I'm one of them, and I have 2 of my colleagues, Philip and Craig, who are also Eplan certified engineers. So again, we are the only 3 in this region: Australia, New Zealand, Southeast Asia, possibly in the Southern Hemisphere as well. The rest of them are mostly in Europe, and there's a few in the US and so forth. So it's quite a stringent exams that you sit, and 3 levels of testing, and it's run by an independent university out of Germany. So we are electrical and control design engineers ourselves, and we use Eplan P8 on a daily basis. We also use ProPanel for 3D panel layouts, and we use the Schematic generator, the ESG, which I'm going to touch on, and Tools, which is a collection of apps. There's about 12, more than 10, 12 apps in there that we bring together. And this basically helps our clients with their efficiency and just miscellaneous tasks that Eplan does not have a feature for. We create those features and put them into a collection, and we share that with our clients. So our core focus is to create efficient design solutions, and the way we do that is by automating the design process. Again, I'll touch on that a bit later. So we offer our design and engineering services to quite a wide range of clients. Mostly OEMs and manufactured plant and machinery. We do quite a bit of work in the dairy industry, baggage handling systems, material handling systems, switchboard manufacturing, water, wastewater, and many other industries. So we have completed over 1,200 projects ourselves. So we are vastly experienced in Eplan. And one of the things that we specialize in is creating these bespoke solutions, these customized and optimized workflow solutions. And we've created these solutions for quite a few different clients in different industries. OEMs that manufacture baggage handling systems, for example, there are 2 large OEMs here. We've created solutions for them. We do quite a bit of work in the dairy industry. For some of the big players in the industry, we've created solutions for them. The food and beverage industry as a whole, that's quite a big industry here in New Zealand. Fruit sorting systems, whiteware manufacturing lines. There are 2 large whiteware manufacturing OEMs in the country, and we've created solutions for them as well. Packaging machines, packaging lines, material handling systems, petrochemical, not that much, but yeah, we've done a bit on that, on the petrochemical and chemical industry, switchboard manufacturing, and many other industries as well. So let's talk about engineering today and some of the challenges that we face. Of course, our engineering costs in New Zealand, labor costs are not cheap, and labor costs are not cheap. And together with skills shortage, that drives up engineering prices. And once you have good engineers, you need to retain them, and to retain those skills, again, are not cheap. So on a whole, we have quite high engineering costs here. We've got also high manufacturing costs, and more recently with the fuel crisis and the war in the Middle East, that's driving up inflation. So that's having an impact on manufacturing costs. Then we also got high software costs. As most of you will know, Eplan is not exactly the cheapest software out there, and clients want a return on their investment. While all of this is going on, we still need to maintain our design integrity. Clients want the best quality and the highest levels of accuracy, so that in fact is sort of non-negotiable. And of course, companies want to stay in business, and to stay in business, you need to stay in the game, and you need to be competitive, and you need to be profitable. So there are many challenges out there. Of course, there are solutions as well. And so we'll just run through some of the possible solutions that we can offer you, and Eplan can offer you. So it all starts with just being smarter about the way we do our engineering. And that is creating efficient design solutions, but also creating efficient manufacturing solutions. So today we're going to focus on the design side of things, and in the subsequent webinars, we'll be focusing a bit more on the manufacturing side with Pro Panel and so forth. So stay tuned for that. And it all starts off with using an efficient design software. And for us, that is Eplan P8 or Pro Panel. And not only that, but also adding on tools that can accelerate this design process, such as the Eco Schematic generator and our panel layout generator, Eco tools, and so forth. Using standard and repeatable designs. So why recreate the wheel each time? And that's where Eplan Macro technology comes into place, so that we can create these reusable elements. Embracing new technology. There's lots of new technology out there, such as coding, using VBA for your Excel, using C# writing scripts, using artificial intelligence, if you've got those sort of skills, to automate the design process. So we don't have to draw everything by hand. It's just using all these smart tools to help us create more efficiency. Okay, so let's just start with something that's really fundamental, and that's an Eplan macro. And what's an Eplan macro? So basically, for us, it's any typical circuit. If you can draw it, you can create a macro out of it. Ideally, you want it to be something that's repeatable, something that you're going to use often. So it's worth spending the time and creating a macro of that. It could be as simple as a symbol. It could be a circuit breaker or a motor, and that could be, or a coil for a contactor. That could be a macro. It could be a black box. You could create a VSD or a field instrument where there's no standard symbol for that, and that can become a macro as well. It could be an entire circuit, like a VSD circuit or a DOL circuit. That can be created as a macro. It could be an entire page. Sometimes in your drawings, you may have a standard page, like a utilities page, a fan, a GPO, and a light. You have that in every project. So why not create a page macro of that and reuse that over and over again? So ideally, you want to place your macros in a macro project. And I'll talk about macro projects and the difference between that on the next slide, between the macro project and the schematic project, that is. But ideally, you want to create your macros in a macro project. And nothing stops you from copying a schematic project that you've already created and pasting it into a macro project and making it into a macro. So there's ways that you can, things that you can do to minimize the time that you spend creating these macros. And I'll touch on some of them a little bit later. Okay, so what's the difference between a schematic project and a macro project? You may have heard of it, but maybe you don't know the difference. Most of you would be familiar with a schematic project. That's when you create your working project, and this is the project that you're eventually going to send over to your client. This is where you create your schematic drawings, your schedules, your reports, and so forth. You export your manufacturing data, like your bill of materials and cable schedules, and all of that stuff from this project. At the end of the day, you PDF this, you print it or whatever, and you send it off to your client, you send it off to a switchboard manufacturer, and so forth. One of the limitations of a schematic project is that you cannot insert a macro box in a schematic project. Okay, so how about a macro project? So effectively, a macro project is a project, think of it as a library. It's a library of all your macros, basically a place where you store all your macros and you manage it. And this is something that stays in-house. You don't send this to your client. It's your intellectual property. Ideally, you should only have one macro project. I've seen companies have more than one, but I think to manage it, you can manage all your macros in one project. And ideally, again, you need a manager for this, somebody that looks after this, and somebody that will take ownership of your macros. This is where you can create your macros, you can edit your macros, and you can manage your macros. And by creating, I mean you can also copy from your schematic project and paste it into your macro project as well, and create a macro of that. You can insert a macro box to manage the macro. So once you have a macro box, you can determine where you want to generate those macros to. You want to generate that onto your local machine, onto the server, so that everyone can access that. So people to access other users don't necessarily need to have the macro project to access those macros. Once it's generated, it resides on your server, and anybody can access those macro projects. And as I mentioned, the macros need to be generated. So once you create them, there's a button on macro and on Eplan, and I can show you where that is. And you literally press that, and you generate the macro. And it looks at the path where you want to generate that. You define that, and then you press a button and generate that macro, and it will reside in that location. Okay, so let's run through some of the basic macros, like a page macro. So this is a utilities page. You might use this over and over again, so why not create a page macro for this? So every project, this will become a page macro. And you can add this to your template. So in your template project, you can have one of these in there, or you can have it in your macro project as well. A window macro. So a window macro is like a typical circuit. It could be a DOL starter, and you can have different variants of this. In fact, you can have up to 26 variants, A to Z. So when you insert this macro, you press your tab key on your keyboard. You can tab through the variants, find the variant that you want, and you can insert that macro. And I'll show you an example of that shortly. So traditionally, what did we do? We created one circuit, and then we would copy this. We would copy it, and we would paste it, and then we would change the values of the device tags. We would change the components. And this is sort of an old-fashioned way of doing it. Yes, it can be done, but it's time-consuming, and it's really inefficient copying and pasting. There are better ways of doing something, doing this. So, for example, if you create a typical circuit, you could add a placeholder in there, and that placeholder could take care of your value sets. So if you look at the circuit, it looks identical whether it's a 0.75, 1.5, 2.2. The circuit itself doesn't change, but of course the components within that is going to change for your protection. So why not add that into add a placeholder? It's like a recipe. So when you choose a 0.75, the circuit breaker is going to change, and your technical characteristics for your motor will change, or the cable could change, and so forth. So as you change the value set, the components within there would reflect that kilowatt size or that value. How about your device tags? So you can add a second placeholder if you wanted to take care of your tags. It could be a device tags, it could be a description, it could be a contactor DT. So you've got two placeholders that takes care of two different things. And in most cases, your information is residing on an Excel sheet. So what we would do, we would bring up this Excel sheet, and we would copy and we paste, copy and paste, copy and paste. Again, inefficient. So why don't we take the information from this Excel sheet and write it directly into the macro and generate these drawings instead of us manually copying and pasting. So that's where the ESG comes in. So ESG stands for Eco Schematic Generator. This is something that we've developed. It's an in-house development from us. It works seamlessly with Eplan. There's no installation as such required. All you have to do is load a DLL file, and we'll provide you with a DLL file. You load that. To use any of the APIs, you need the API runtime, and that is something you would buy from Eplan. It's not very expensive. It's a few $100s, I think like under $300 or around about $300 per year. So in the big scheme of things, it's not very expensive. And once you have the API runtime, you can then utilize our macros or our API, sorry. So I'll just run through this Eco Schematic Generator. We've got different methods in which you can generate schematics. And we've got a very basic method via an embedded form. So if you don't want to use Excel for whatever reason, you can't be bothered with it, there's an embedded form. You bring up the form, you insert your macro, you put the page that you want to generate this, press a button, it's going to generate it for you. So this is a very simple embedded form method. Then we've got a slightly more advanced method, which is an Excel. So you interface into an Excel, you can insert your macros into Excel, and you can populate those variables. So the variables will come up, the value sets would come up. You can manually select your value set, populate those variables like your device tag, press a button, and generate those macros. Then we have a third method, which is also Excel based, but your Excel has more automation. You create VBA code in there. So instead of you manually going and typing the variables in there, you might have master data, you might have an IO list, you might have a motor list. So why not copy that information from that IO list or the master data into those variables? So it saves you from typing them or copying and pasting. So you're using code to actually get this done for you. It's not very difficult. A lot of people have got VBA skills these days, or know macros in Excel. We can help you with this as well. We've got those skills, but we leave it up to you. If the client has those skills, they do it themselves. If they want us to help them, we can help you with this as well, create the solution. And once you've sorted your data and you've prepared everything, the next step will be to auto-generate those drawings. And you can generate a single tab in your Excel, or you can generate multiple tabs. Again, I'll show you an example of that shortly. So this is an example that we're going to go through now in the live demo. I take information from a device layout or like a PNID. This is a conveyor system. I'm going to extract that information, the raw data from there, load it into my auto generator, and then I'll do a bit of sorting and manipulation, and then write that information directly into a macro, literally press a button, and I'm going to generate those drawings for you. So this is more the automated solution, and show you what is possible. Okay, so we'll jump into the live demo now. So let's minimize this, and I'll get into my Eplan. So I take it most of you can see my Eplan now. So in here, I've got two projects. I've got a macro project and I've got a schematic project. So I'll just run through the macro project very quickly. So yeah, I've got a whole lot of macros in here. And how do you create a macro project? So basically, if you right click anywhere on the project title, if you go into properties, you'll see here type of project. And in this case, I've selected, I decided to make this project into a macro project, and there's a drop down here. So you can choose between a schematic project and a macro project. So this one is a macro project, and it's selected and created as a macro project. So let's run through some of these macros. So here's my demo macro and a page macro. So this is our power distribution page. This is something that I would use on a regular basis. So I'll create this into a page macro. I've got my e-stop zones in here. And I've also got a placeholder in here to manage the value set, because the circuit breaker might change. It may not be 100 amps, it might be 160 amps, it could be 200, 250 amps. So I've got a placeholder in here. I'll just double click on it and I'll show you the value sets. So if I change this to 100 amps, the circuit breaker is going to change and the handle is going to change, or 160 or 250 or even 400 or 630 or whatever I want to. I can add as many value sets as I want to. All I do is I right click and I'm going to add a value set here. Okay, and once that is done, I can then right click and I can go and assign the value set. So for example, let's bring this over here. If I want to change this to 160 amps, I change that to 160 amps. Those components are going to change to 160 amps. And now that's changed to 160 amps. So once I've created this page, the next step will be to generate this. So I'll just right click and go into the properties, move the screen across. And here you can see the macro name, and this is the path where I'm going to generate this macro. So it's available to my colleagues and so forth. So they don't necessarily need to have access to this macro project. So this is a typical page macro, and I'll just run through a few page macros. Again, here I've got a power supply and I've got a 24-volt distribution. But the same thing here, I've got a 10 amp power supply and I've got a circuit breaker. So what if I change this to a 20 amp? Note, watch the circuit breaker. So I've got a 4 amp circuit breaker in here. So if I go right click, assign value sets, I'm going to change this to a 20 amps. And note my circuit breaker changed accordingly as well. So what you can have is multiple components assigned to a placeholder. So that when you change it in one place and it could affect multiple components. Okay, so that's as far as the power supply. I've got an Ethernet switch, which is a fairly standard page macro here. I've got an HMI, excuse me. HMI, again, a fairly standard page. And you could have something as simple as a 400 volts bus. And the reason I got this page is that, so the next time I want to insert, I can insert a VSD or I can insert a DOL, window macro, in conjunction with this page. PLC overview. I've got some Siemens modules here. I didn't create these modules from scratch. I downloaded them from the data portal. So you can download these modules from the data portal. You don't have to draw everything from scratch. Got some input modules. These are my overview. Got some output modules, some safety modules, all downloaded from the data portal. I'll just jump forward here. I'll come to this DOL starter. So here I've got a DOL starter and I've got different value sets in here. So I've got a 0.75, 1.5, 2, 3, 4, 5.5, 7.5. So I can have as many as I want to. So whenever I change this, the circuit breaker is going to change and the technical characteristics on my motor are going to change. I've got a second placeholder in here to handle the variables. So my tags in here will change and they get assigned to this placeholder here. So in here, I created one for device tag, the contactor DT, and the description. Okay, and they are assigned to these components here. So in here, you can see I've got a few different types of brackets. I've got a sharp bracket. So basically, I'm writing this contactor DT. So when I get to my Excel sheet, I'm going to write whatever that DT is, whatever the page, just say 40K1. It'll automatically write 40K1. And the next one might be 40K2 or 40K3 and so forth. Then I've got my device tag. And you notice I've used one device tag or one variable multiple times here. So here I'm going to write device tag and it's going to get concatenated with W1. Then device tag concatenated with V and W2 and M and so forth in here. Then I've also got some other variables in here that takes care of itself. The ESG takes care of itself. We don't have to do anything in here. And these are the normal brackets. So it's page, and in this case, the identifier for the terminals are X, and we've got a counter. So if I'm generating this particular drawing into page 20, it'll write 20x1. The next one will be 20x2 and so forth in here. And that takes care of itself because the ESG knows it's generating into page 20 and it'll automatically write this for you. So you don't have to worry about creating a variable for that. So I'll show you some of the tools that we've got. So if you look at this particular placeholder in here, to create this from scratch, you will need to define the variables and then assign these variables to the different components, like your circuit breaker, your cable, your isolator, your motor, and so forth. So that can take a few minutes to do, but we've created technology to help you reduce this time as well. So I'm going to delete this placeholder in here, and I'm going to insert a new placeholder. So if you go to Insert, Navigator, Insert a placeholder object, I'm just going to select this device, and I'm going to place this in here. You can see there's no variables in here, and I've just got one component, which is that the switch that I've just selected, but there's no assignments or anything in here. So I'm going to go OK. And under our Eco Tools, we've created an API to help you auto-populate this. So it's going to loop through this macro, find all these variables, and it's going to write it directly into this placeholder. So all I do is I select the macro box, and I go to our Eco Tools. We need to move this aside. Eco Tools, and here we've got something called Adopt Variables. And I'll just give it a couple of seconds. as it loops through the macro, it's gonna assign this automatically. So it's done that. And if I double click on it now, you can see it's created those variables for me, and it's assigned them at the same time. So that again is in our tools that we've created to help you faster create these macros, and not everything has to be manually done. So again, EcoTools will be another presentation on another webinar, but we've created a number of these apps in here to help you speed up the design process. So same thing with the VSD. Here I've got a VSD, and I've got two placeholders in here, one to handle the value sets, and the other one to handle the variables. So in this case, I've just got two variables, the device tag and the description. Once all of this is done, I'm going to generate these macros. A window macro is slightly different to a page macro. You double click on the window, on the macro box, sorry. You double click on the macro box and you determine the path where you want to generate this macro. You can also define the type of macro. In this case, it's a multi-line schematic. It's variant A, and this is where you choose your variant, A to Z, and which version of this macro it is. It's a version A, and it's my VSD. Okay, guys, so that's as far as the macro project is concerned. And I'm going to jump onto my schematic project. And in here, I've got my title page, I've got my table of contents, only got a few drawings in here. And I've got two device layout pages, which I'm going to extract. So this is a typical conveyor system, a very simple system. The pallets or baggages or whatever comes through here, it can be anything. I've got my photo eyes, I've got my starters, DLL starters, more photo eyes, my e-stops, and so forth in here. My MCC is located here. I've got some VSDs on the far end here, and I've got more e-stops and photo eyes dotted around the place. And it exits here, and I go on to the next page. And here I've got an X-ray system, and the pallets or bags go along here and ends up in this lateral here. So here again, I've got a lot of devices, and some of them are mounted on. So some of them are connected onto the drive. These are all remote I/O, remote devices. I've got some IO link modules. Some of the devices are connected to IO link. Some of the modules are connected to the drive itself, and the drives are on Profinet, and so forth in here. So there's all of the devices in here. So what I'm going to do is I'm going to extract this information, load it into our ESG, and show you how you can auto-generate these schematics. So I'm going to select these two pages, and using a standard Eplan function, that's the labeling tool. I'm going to extract this, and I'm going to export this and start the application. Let's bring it over from my other screen. So here you can see that. This is all the raw data, basically. And that's extracted. This is a standard Eplan function, no API or anything else involved in here. And the next thing I'm going to do is I'm going to bring up my ESG, and I'll just place it here. And so basically, I've got these two sheets next to each other. I've got my raw data here, and I've got my ESG here. So I'm going to load this raw data onto my ESG now, and I've got a load function in here. And there's only one other sheet open, so I'm just going to import that. So basically, I've imported my raw data in here. And it's just done a sort. It basically sorted my devices, grouped them together. So I'm done with this. I can now close it. I don't want to save that, and I'll maximize this. So I've got my raw data. The next thing I want to do is I want to create a schedule. I want to create an IO list, and I want to create a schedule for all my field devices. So in here, I've got a button that's going to create my schedule for me. Again, guys, this is all VBA code. Most people, a lot of our clients have got skills, or somebody in the organization has got skills to create this. We can provide some training for you on how to do this. Or alternatively, if you don't have the skills, we can help you develop this for you. So I'm going to create a schedule. And here I've got an IO list. So it's taken all that information and just basically created an IO list for me. And I've got a field schedule as well, all my field devices in here. With my device tag, the type of, whether it's VST or DOL starter, the kilowatt size, the description of it, where is it connected to, which e-stop zone it belongs to, and so forth. And the devices that are actually connected to this drive. So here I've got some encoders or pulse wheels connected, and I've also got some photo eyes connected to that drive. Then I've got some IO link modules here, and these are my 4 ports and the devices that are connected to that. So the next step is that we break this project down into manageable sections. So anything related to a starter, we'll have a starter tab. Of course, you can have everything in one tab, but our preference is to break that down so it's easier to manage, easier to fault find, and so if you do have a problem, you can solve it as quick as possible. So basically, what's going to happen now? I'm gonna insert my macros, and it's going to look at my schedule. It's going to look at my field devices, and it's going to ask the question, so how many starters do I have? Which starters do I have? Do I have VSTs? Do I have DOL starters? And it's going to bring through the macro. It's going to write a path. So let me insert that. And what you'll notice is now it's written the path where these macros are residing. So for example, in this case, it's on my local machine, and it's now written the path and where I want to generate this. And the next thing that's going to happen is going to manage this, and I'm just going to make sure that I'm connected to my ESG. Just going to bring up my ESG and just make sure that my setting. Oh yeah, okay. Now it's connecting, and now you notice it when it searched to this path, we have found the macro and it's brought up the variables. It brought up the variables here. Of course, at this stage, I can go and type them in, type whatever the page description is, the motor size, or I can use a drop down to determine the value set or the device tag. But again, we want to use code. We want to automate this whole process. So I'm going to press this button here, and I'm going to import the variables. It's looking at my schedule, and it's going to bring these variables in. So literally a click of a button, and it's going to import those variables. The next tab is my PLC overview. I'm going to do the same thing as well. It's going to look at my IO list and say, okay, these are all the modules that I need for my PLC, and these are the variables that belong to these macros. And now I'm going to auto-populate those variables. Same with my digital input. I'm going to insert the macro. So it's looking at all my devices, and I need running feedback. I've got some photo eyes and so forth in here. And now I'm going to auto-populate that using code. So I've got a few other tabs which I've pre-prepared just to save time. And once all of this is ready for me, I can now generate my drawings. And I can generate either one of these tabs, or I can generate several of these tabs. So I'm going to minimize this. I can generate it from here, by the way, or alternatively, I can go back to my ESG, and I can generate it from here. So before I do that, I'll just show you this settings page in here. So basically, the settings is a dialog box where you can select where your macros are generated. So if I click onto this, I can choose the path where the macros are generated to. I can select the project. In this case, I only got one schematic project open, so it's going to select that schematic project. And here, which Excel sheet am I referring to? And I've already got one Excel sheet open, so it's pointing to that Excel sheet. So this is my Excel sheet, this is my Eplan project, and these are where my macros are residing. Just basically 3 settings. And once that is all good, you get a nice green tick here. Okay, so now it's time for me to generate my drawings. And here I've got a generate button. I can generate, as I said, one tab, or I can generate several of those tabs. I'm going to generate several. And that's going to bring up a dialog box. I'm going to select which tabs I want to generate. I can also generate my reports at this stage, but I'll leave that for now, and I'll show you how we do that later as well. And I can bring them across. These are all the pages, all the tabs that I want to generate, and I literally press the generate button, and it may take a minute or so to generate. Guys, it's a small time price to pay, because to create the schematics will have taken you probably a couple of weeks. Of course, there's an investment in creating the macros, but it's reusable. So once you create these macros, you don't have to create them again, and they can be reused over and over again. So this type of thing is ideal solution for OEMs, people that are creating repeat machinery and so forth, and even system integrators that you may work in a particular industry, water, wastewater, or something like that, and it could be very similar. So it can be adopted to just about any industry. So here's my drawings created, including my remote I/O. I'll just run through them very quickly. So this is the page that I showed you earlier on. It's my power distribution page, and they're all connected to my e-stops. My e-stop zone 1, 2, and 3 are connected. My kilowatt sizes for my contactors based on my e-stop zone have been calculated for me, and they're sized accordingly. The circuit breakers have been sized, and also the cross references and everything are all working for me. Then I've got my power distribution going out into the field, and the same thing here as well. They're all connected and they're all cross-referencing. The utilities page, this is a fairly standard page, so there's not much we did in here. Got my power supply, and we've chosen a 10 amp power supply. But just say, for example, I decided, I don't want a 10 amp now. I changed my mind, or the project has grown. I want to change this to a 20 amps. I can change this quite easily to a 20 amp power supply. So although this project has been generated, nothing stops you from doing manual changes to that. My switch, my HMI, and I've got my DOL starters. Same thing with the starters. If the project has changed, all you do is you right click onto the placeholder, and you go and change that value set here. I've got a cross reference into my PNID, so if I press F on my keyboard, that's going to jump to my PNID. Okay, page down, more DOLs. I've got my VSDs here. There might be a little bit of tidying up at the end, closing off this bus, but it's a couple of seconds in the big scheme of things. Page down, my rack overview, PLC rack overview, my running feedback for my DOLs, my photo eyes, more photo eyes, my e-stops, more e-stops, my contactors for my DOLs, and my safety zones. Back to my PNID. And these are my remote I/O pages. So yeah, I've got some devices out in the field, VSDs, and I've got some devices connected to that. More of the same. And these are my overview for my Profinet. Just basically showing all the devices are connected and looped through. And I've got my IP addresses and everything all defined for me. This is my IO link module, and I've got some devices connected to this IO link module. It stops. And I've got a beacon sounder here and a control station. Pretty much the same thing here. Okay, guys, now that my schematics are done, the next step is to generate my reports. As I mentioned, I could have done it from the ESG as well, but I'll just run through this again to show you. I selected my project, and in here, I'm going to generate my reports. And under my templates, I've got all my reports predefined, the reports that I use on an ongoing basis. And I select the project and literally press generate reports, and within a couple of seconds, it's going to generate all my reports for me. So under my reports, I summarize a parts list, and my field parts are highlighted in yellow. Page down, more field parts and my MCC parts, more of the same. My termination diagrams, there's quite a few of them. I'll just scroll through. I've got a cutting list. Something happened here. Okay. I've got my cable schedule. Cable schedule here. I think because I've deleted the panel layout. That's the reason I'm cutting this. Probably can come off. Anyway, I've got my cable pulling schedule. More pulling schedule, and I've got my connection lists here. Because this project was created in 3D, I've got my wire extractions here. Okay, guys, my schematics are pretty much done. The next thing I'll show you is how we can generate a panel layout, both in 2D and 3D, where we can insert the DIN rails and trunking very quickly. So again, I'm going to generate the 2D panel layouts into my MCC section in here. So under my ESG, for those of you familiar with the ESG, you'll notice we've got two additional tabs in your two additional features in here. Panel generator 2D and panel generator 3D under our PLG basic. So I'll go into the panel generator 2D and bring up this dialog box here. And if I click on the three dots in here, I can browse to where my macros are created. So these are my macros, Ecodesign, and these are all the retail macros that I have. If I go into, for example, TS, I can see all the macros in here. And the way you get these macros is by downloading them from the data portal. So if you're looking for an enclosure downloaded from the data portal, these macros automatically get placed into your master data, into your macro folder. You just need to browse for the macro. If it's a 2D panel, of course, we'll browse for the 2D macro. If it's a 3D panel, you need to browse for the 3D macro. And once you select a panel, you notice it will dynamically change the mounting panel width and the mounting panel height. I'll go back here. So this is a fairly standard panel, 8204 500, 1200 wide, 400 deep, 2 meters high. So the gear tray is roughly about 1100 by 1.9, normally about 100 millimeters smaller than the actual enclosure. The trunking width, I can go and select my trunking width. So I'll select 60. My spacing, horizontal spacing between the trunking. So I'm mapping at 250. Do I want to offset at the top? Yep, let's put an offset on the top 50 millimeters, offset at the bottom 50 millimeters. And where do I want to generate the external panel layout? I want to generate the external panel layout into page 101. And I want to generate the internal panel layout into 102. So let's make that 102. So this is the part, this is the page. And here I can determine where I want or which trunking I want. Do I want a left or I don't want a left? Do I want a middle trunking? I can select that or deselect it, right, and the horizontal trunking. Do I want gray trunking or white trunking? I like gray. And once I've got all my settings done, within a couple of seconds, I can now generate this panel layout. And almost immediately, I've got a panel layout. The external panel layout has been generated for me, just using that macro. And my internal panel layout, DIN rails and trunking, have been generated for me. Now, guys, this would have taken, maybe half an hour of somebody's time to create all of these, and within literally, 1 or 2 seconds, you can create this using this application. And now it's just a matter of dragging and dropping those components in the same way as what you would do with any other panel layout. Not remote IO, MCC. I'll just take these circuit breakers. You can just grab these circuit breakers, right click, and you can place onto your mounting rail. I'll place it onto this mounting rail here. Let's go enter, 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 enter. And that's done for me. And if I want to tidy up that, I can just right click, go into my properties. Right click, go into my properties and into the part placement. And I'll change the display. I've got a setting here, demo. And it's just going to tidy up my descriptions and my legend numbers. Okay, so the next thing I'll do is I'll show you the 3D version of this. So this project here has been created in Pro Panel. So I go into my layout space, and I need to create a layout space here. And all you do is you right click and go new, and you create a layout space. So this is my MCC layout space, and now there's nothing in there. It's pretty much blank. I'll just close this for now. And I'll go to my 3D mounting panel, 3D panel generator. I need to select the mounting space, the layout space, and it brings up this dialog box. Looks very similar to the 2D one, but in this case, you need to select a 3D macro. And if I go in here, I've got some 3D macros in this folder, and I've already got one that I've selected. So I'll generate this one here. It's a VX. Again, it's a retail panel. This is the new series, the VX, and it's pretty much the same size panel as what I used with the TS, 1200 wide, 400 deep, and 2 meters high. You can see the gear tray shows up here. The trunking width, again, I'll keep it at 60. The spacing 250. My top clearance 50 millimeters. My bottom clearance 50 millimeters. Do I want a center trunking or not? Again, it's exactly the same as a 2D. And once I'm done with that, I can generate this. And within a couple of seconds, I'm able to generate a 3D panel layout with my DIN rails and my trunking. So if I just expand this and I go to the mounting panel, yeah, I can see that. So again, this saved me, maybe 10 or 15 minutes work doing this manually. And now it's just a matter of dragging and dropping those components in here. I'm going to use a cube as well. And I'll go to my 3D panel navigator. And I'll do the same thing. I'll pick up those circuit breakers, right click and place. Where do I want to place them? Just place them in here and enter, and it's done. Go back to my isometric view. Now you can see the circuit breakers are pretty much done for me. So guys, that's a very quick demo on some of the tools that we have and some of the tools that we've recently created. Just go back to my PowerPoint in here. Just a bit of a recap on some of the key benefits of design automation. Obviously, there's a significant reduction in engineering cost, as you've seen. What would have taken you maybe a couple of weeks to have done manually, we can generate that in a few minutes or in an hour or so. And we do that by utilizing Eplan macros, leveraging the Excel, VBA, our ESG, our PLG, and that you can achieve savings of up to 70%, and that's a conservative number. It can be even more. The more effort you put into your macros and your VBA, the closer you can get to generating 90+%. Faster project turnaround. We spend more time on our design and less on the actual CADing because it takes care of itself, and that's going to streamline your workflow, drastically reduce your project timeline, and of course your return on investment as well. Error-free deliverables. Of course, if your macros are created properly and accurately, if your master data is accurate, you're going to generate accurate drawings as well. Error-free schematics and reports. Reusable elements with macros. Of course, you can repurpose those macros for future projects as well, and that's going to further enhance your efficiency. Everyone wants to stay ahead of the competition, and this is one way of doing that. So irrespective of the industry, whether you are an OEM creating machines or a switchboard manufacturer or a system integrator, you can reuse the solution for your applications. And it's sustainable and scalable irrespective of the project size.